Hello, my name is Mustafa Melih. In this part, I'm going to cover two ANOVA and MANOVA. Since there is no test for MANOVA, I just want to talk about how it looks, how the data is formed. So, as I told, you have one independent variable. It's the types of fruit, and you will have multiple dependent variables. The test name is multiple analysis of variance, so you will have multiple analysis of dependent variables. There is no test for this one, so I'll advise you to do it one by one. So take normality of this one, see if it's normally distributed. If not, do Kruskal-Wallis. See this one, like this, and do it like those, or download SPSS and do it from there. I can show it by in the SPSS part, but I'm going to continue with 2 ANOVA. So let's see what 2 ANOVA is. You'll have two independent variables. So let's see our independent variables. We have as one our independent variables, one E. It is type of wire. It is the type of wire, and another E independent variable is the centimeters. So these are two independent variables, and you place it like this. And as our dependent variable, we'll have resistance. Let's see our assumptions for it. The assumptions for 2 ANOVA and MANOVA are same with 1 ANOVA, so you can have it like that. I come to here. Let's see. First is normal distribution. Let's see, our data is normal distributed. I stack them on top of each other so that it's easier to put it in the test. I'll just copy them and paste them with Control C. I come to calculators, homogeneity. Let's see, calculators, Kolmogorov Smirnov test of normality. Place it there, select, let's see if any spaces, if there's, delete them, calculate, and P is larger than 0.05. Let's see what does that mean. We know our alpha value is 0.05. It's always 0.05. So if it's larger than that, if our P value is larger than that, 0.05 alpha value, we accept the null hypothesis. If it's smaller than that, we reject the null hypothesis and accept H1. So let's see. Since our P value is larger than a alpha value, we'll have to accept the null hypothesis. So our data is normally distributed. So we met the first assumption. Let's see. Let's see our second assumption. It is no outliers. I come to descriptive statistics, percentile calculator, place my data here, and let's see our quartiles. Q1 is 0.54, and Q3 is 1.25. Interquartile range, I take Q3 minus Q1. Lower limit is calculated by Q1 minus eta quartile range multiplied by 1.5, and I calculate the upper limit by adding Q3 plus, this time plus, with interquartile range multiplied by 1.5. We see that none of these values exceed 2.2. Yes, and there are no negatives, so I see that we have met the assumptions. Let's see if we have equal variances. I come to this site, and let's search for Levin's test, and Levin's test for equal variances. I don't change any of these since I'm going to put my data directly in it. I select my data like this, one by one, and this one as well. and this one as well. And we'll check if these variances are homogeneous. And I take my p-value. Let's see. Lemma test of homogeneity 0.05. So since our p-value is larger than 0.05, we have to accept null hypothesis. There is no difference in variation between the groups. So we say that our data is homogeneous so that we can conduct our analysis of two-way ANOVA. I come to, in this site, statistics kingdoms, I come to statistics kingdom, two-way ANOVA test. I don't change any of these except this one. No, I don't need to change it since I didn't exclude any of them. So outliers included. So what is this? You don't need to think about this. You'll use generally fixed effect. So you don't even need these. Do this one step by step. I come to here. So 1.00. So insert row. I change it to 2 centimeters. Insert row. One more. I change it to 3. Insert row. Yes, 3. Yeah, we'll have, yeah, like this. And I'll add another column since we have 3. Category B is copper. This is aluminum. This is a gold wire. Okay, I come to here. Unfortunately, we'll have to type it one by one in the site, so I'll put it like this. How did I do this? Select Excel, come to with your cursor to the right side of it, and then select the thing that you want to put it there. Fairly simple. And then I put the data like this. And let me not take your time. I'll come back when I do it. So I put my data in my calculator, make it larger, and then I calculate. Let's see. Our p-value for columns, so these are the columns like this. So we have in our since we had 2 independent variables, we say that in the categorical independent variable we had a significant difference since it's showing columns. In rows we didn't have, so the centimeter of the wire does not affect in this sense, doesn't affect the resistance or index circuit, but the type of wire does. We come from this. So let's see the post-hoc analysis if we have them. So we don't have the post-hoc analysis. I have a solution for it if we don't have it. 2K. No. Banfora. No, we don't have it. So I come to this link, graphpad.com. The problem with working free sites is I don't want to teach you guys with like SPSS or hand calculations. That's why I'm doing the free stuff. This is the best that I can do. There is no postdoc here, but you can use this postdoc. But for Kruskal, for other stuff like for non-parametric ANOVAs, this site won't work for you since you need the MS value, which is right here, mean square, and you'll need residual, which is error values here. This is degree of freedom, and mean square. You'll need these values, which is not. I don't want to like confuse you with. So you'll need to do it on this side, like Cruz if you want to do it Cruz you'll need to do on this side. If you want to do two ANOVA, you'll need to use this side. So it's a little bit complicated. If you but you just follow what I do, it's easy. So I take, let's move them over here so that I can move between them easily. Let's see our mean squared for error. Mean squared for error is this. Put it in here, and degree of freedom is 16. Place it 16. Let's see. Do we have the means here, or will I need to calculate by myself? Okay, we can calculate it just here. We'll take the averages of these. Average of these like this. So for, let's come to post-hoc. Mean one for one. Let's do 0.85, 0.85. This one, and put it here. Oh, let's see how many values are in there. It has 9. 9, 9, 9, 9, 9, 9. When you select something, it appears here. So I saw it from here, like see this part? You can just see the number of boxes that you select from this corner. So I saw that 9. And I'll calculate now. Alpha is always 0.05. And yes, all three groups are significant. We see it doesn't give the p-value, but that's the best that we can do. I couldn't find any other sites than this for post-hoc, so we'll have to do with this one. We won't be able to give the p-values, but you can, if you want to like screenshot this, and if you want like more detailed screenshot this one, yes, like that. These will show if it's significant or not. All three groups are significant, and the centimeters doesn't affect it. So we found it. Let's draw the graph of it. Let's graph these. Since it's like one-way ANOVA, you can we'll do the same stuff that we did with one-way ANOVA. I'll do standard deviation samples. Select all of them. And by the way, I come to take my cursor on top of this little box on the right corner of it, of this thing, and then I just shift it left so that it would copy the equation that I put here to these boxes that I provided. And let me delete this one so it will not distract you. So I select these, I press Control, select these three, insert a bar graph like this. I have my bar graph now. I add error bars like this. I shake it a little bit if you don't have the plus value, plus sign here. I come to plus, error bars, this little nibble thing here, more options, custom, specify value, and let's specify the value. I'll delete the one here, select here, delete one, select here, bam, you have your error bars like this. And if you want to use like the error bars and these means as well, we know that these like these three is significantly different from each other, but it's not easy when it's easy to see this when in this format. We draw it for this data. It may be easy to see, but in other data or some type of another experiment, you'll need to use different stuff. So do it like this. You graph it, you see the difference. This aluminum wire has the largest resistance value, and successively this has the largest one, and has the least one. So we compare it like this, and error bars show that if the error bars overlap, we say that there is not a significant difference. So if we see the bars like the axis or x-axis of overall, like these error bars overlap, since they don't, we say that the value is significant as well, and we prove it with graphing, proved it with graphing and two-way ANOVA as well. So that's it. Thank you for listening. Have fun in your life.